Hello students! An occupational hazard is any workplace condition that causes a risk to employee health. Occupational hazards can be biological, chemical or psychological, but because this is a physics course, we will discuss physical occupational hazards. Occupational diseases and injuries are preventable. Organizations have a legal duty to put in place suitable arrangements for health and safety. Work safety should be an integral part of workplace behaviors and attitudes.
In Finnish workplaces, non-Finnish speaking or limited Finnish language workers might be at disadvantage in understanding and learning safety concepts. Language barriers can lead to additional occupational injuries. I wish to encourage you to learn Finnish and intercultural communication in the safety context. Physical agents in work environment are sources of energy that may cause injury or disease to workers. For example, kinetic energy causing vibration. Other examples include noise, radiation, and electricity. Workers should be appropriately protected from excess exposure to these factors. Extremes in environmental conditions, including heat, cold, humidity, and pressure, are also potentially harmful physical agents. Temperature extremes are found in many occupations. Pressures above or below atmospheric pressure in the worker's surroundings are found in certain occupations such as undersea diving and aviation. Many types of pressure equipment can also be hazardous. Physical hazards also include ergonomic hazards, ergonomiset vaarat, like repetition, awkward posture, forceful motion, stationary position, and so on. Exposure to hazardous noise is the most common occupational risk. Sound, ääni, is a longitudinal wave which consists of rarefactions and compressions traveling through a medium. Sound can not travel through a vacuum because there are no particles to carry the vibrations. Unwanted sounds are known as noise, melu. Noise exposure, melualtistuminen, can affect health in two ways. On the one hand, there are auditory effects. Noise exposure is the primary cause of preventable hearing loss. The second group of noise-related effects comprises non-auditory ones. For example, increased stress, sleeping problems, and mental health. The decibel, decibeli, is a logarithmic unit used to measure sound levels. The decibel scale expresses the ratio of two quantities. When the sound power values are expressed as logarithmic values after comparing with a reference quantity, the results are called sound power level äänitehotaso. The sound power level indicates the total acoustic energy that a machine radiates to its environment. To produce an increase of 10 decibels, you need to increase power in watts by a factor of 10. The logarithmic scale also means that the power levels in dB cannot be simply added to get the resulting level. Doubling the power of a sound does not lead to a doubling on the decibel scale, but instead to an increase of 3 decibels. For example, two hammer drills, each generating 100 dB of noise, would produce a combined noise of 103 dB. When the sound pressure values are expressed as logarithmic values after comparing with the minimum audible sound, the results are called sound pressure level äänenpainetaso. The sound pressure level is a measure for the effect of the energy of a sound source and depends on the distance to the source and acoustic properties of the surroundings of the source. The quietest sound a person can typically perceive, also known as the threshold of human hearing, is approximately 20 micropascals, which is an incredibly small disturbance of air pressure. The sound pressure of average rock concert is about 20 pascals, which is the threshold of pain for most people. A gunshot that can cause a hearing loss can have sound pressure of 200 pascals. The ratio of the pressure of gunshot sound to the limit that ears can hear is about 10 million. A logarithmic scale is a useful way of displaying numerical data over such a wide range of values. When we multiply the sound pressure in pascals by 10, we add 20 dB to the decibel level. Sound being logarithmic means that sound pressure levels decay at the rate of -6 dB per doubling of distance. If a point source produces a sound pressure level of 90 dB at the distance of 1 meter, the sound pressure level is 84 dB at 2 meters. But the next 6 dB reduction to 78 dB means moving from 2 to 4 meters. Measuring noise levels is an important part of a workplace noise control program. Workplace noise is often measured using a sound pressure level meter. You can measure noise at home or in the workplace with free mobile applications, but most smartphone sound measurements apps are not accurate enough to be used for legally required measurements. A 3 decibel change in sound pressure level is perceptible by normal human hearing, and a 5 decibel change clearly noticeable to the ear, but the human ear does not respond equally to all frequencies. The ear of a healthy person is most sensitive to frequencies between 2 and 5 kHz. That's why an A-weighting filter is generally built into all sound level meters. The A filter mimics the sensitivity of the auditory system. A weighting is the standard for determining hearing damage and noise pollution. Measurements made on this scale are expressed as dBA. Sound intensity, äänenintensiteetti, is the amount of energy flowing per unit time through a unit area. The quietest sound on a decibel scale is 0 dB, the hearing threshold. The decibel scale is, as always, logarithmic, and the logarithm involved is the power of 10 of the sound intensity expressed as multiple of the threshold of hearing intensity. That means that a sound 10 times greater in intensity than 0 dB will be measured as 10 dB. A sound 100 times more intense than 0 dB will be measured as 20 dB. A sound 1000 times greater in intensity than 0 dB will be measured as 30 dB. Soft music of intensity 1 picojoule, that means a millionth of a joule per second per square centimeter,
has a sound level of 40 decibels. Normal conversation is about 60 decibels. In Finland, the law determines noise exposure levels that are considered dangerous in terms of the risk of hearing loss. The lower daily noise exposure action value is 80 decibels, and the upper daily exposure action value is 85 decibels, which corresponds to the noise exposure of someone who works 8 hours each day in an environment where they have to raise their voice in order for a person standing just 1 meter away to be able to hear them clearly. A 3 decibel increase in noise levels causes an action value to be exceeded in half the time. If the noise levels in your work match or exceed the upper action value, you must attend regular hearing tests performed by your employer's occupational health care provider. Impulse noise, impulsimelu, is a sharp, short, high-intensity noise, typically caused by explosions, gunfire, sirens, hammering on metal or wood, nail guns, and pile driving. Impulse noise is more likely to cause hearing loss than continuous noise of equal acoustical energy. The impulse noise occurring simultaneously with continuous noise can cause substantial hearing loss in workers. Noise-induced hearing loss is the most frequently recognized occupational disorder in Finland. There are 2 basic types of hearing loss: hearing loss caused by acoustic trauma and gradually developing hearing loss. Noise-induced hearing loss can lead to communication difficulties, pain or ringing in the ears, and an inability to hear warning signals. The first symptom may be difficulty hearing a conversation against a noisy background. Hearing loss can affect either one or both ears. In the European Union, employers must provide hearing protection at noise levels exceeding 80 dBA. And hearing protection is mandatory for noise levels exceeding 85 dBA. Both values are based on 8 hours per day. Workplace noise affects more than just hearing, too. Noise acts as a stressor, and its non-auditory health effects include annoyance, sleep disturbance, cardiovascular disease, and cognitive impairment. Exposure to noise can lead to a drop in productivity levels. Studies have shown that people working in places with good acoustic quality have higher work performance than those working in places with poor acoustic quality. Sounds will reflect off hard surfaces such as windows, desks, and floors. Softer surfaces help to control unwanted noise. Acoustic panels made of noise-absorbing materials are used widely in workplaces. Vibration, tarina, is a periodic process of mechanical oscillations. Oscillation is the repeated back and forth motion of a particle when displaced from its equilibrium position. Vibrations can be described by frequency, amplitude, phase, and shape. The mechanical energy of the vibrating object can be dissipated to other objects. Workers driving vehicles, just as trucks and forklifts, are exposed to whole body vibration. Workers standing on vibrating platforms are primarily exposed to foot transmitted vibration. Vibration can cause health effects. Drills, powered saws, and electrical tools such as grinders involve vibrations which is transferred from the tool to the hands and arms of the person holding the tool. This can lead to a syndrome called vibration-induced white finger, valkosormisuus. People who need to use heavy machinery and vibrating tools should always use anti-vibration gloves, work with vibration-absorbing tools, check tools are properly maintained, and keep cutting tools sharp. Encourage blood circulation by keeping warm, stopping smoking, and massaging and exercising fingers during breaks. Lighting valaistus includes the use of both artificial light sources and natural illumination by capturing daylight. General lighting, yleisvalaistus, is intended to light up a room in its entirety. Task lighting, kohdevalaistus, is a bright, focused light that is dedicated to increasing illuminance to better accomplish a specific activity. An example of a task light is a desk lamp. Poor lighting at work can lead to eye strain, fatigue, and accidents. If you heat up an object, it appears to glow. Depending on the temperature that the object is being heated at, the glow will be various colors. Light color temperature is therefore expressed in the unit of absolute temperature, Kelvin. Lower color temperatures are called warm colors. Warm yellowish lights are good for relaxing. Color temperatures over 5000 kelvins are called cool colors. Cool white lights are best for working. Lamps are also labeled with their light output in lumens. A bulb will appear to be brighter when its lumen rating is higher. Illuminance, valaistusvoimakkuus, is the amount of light falling on a surface. The unit of measurement is lux, luxi. It is equal to 1 lumen per square meter. The level of light is measured in lux using a light meter. To determine the light levels in the workplace using a lux meter, remove the sensor cap and place the light meter on the work surface, such as a desk. The European standard specifies lighting requirements for humans in indoor workplaces. This table gives examples of some of them. How much light is needed in a room depends on the tasks being performed. The more detailed the task, the greater the light requirement. A shadow, varjo, is a dark area where light is blocked by an opaque object. Shadows can be helpful in creating a sense of dimension in a space, but they can also be hazardous because they can obscure objects, which can lead to accident and injuries. A shadowy stairway may cause a misstep. If a worker is walking in a shadowy area, they may trip over objects that are difficult to see, or they may bump into other workers or objects. To minimize the safety hazards associated with shadows in the workplace, it is important to ensure that the work area is well lit and free of clutter. Shadows at the working desk may make it difficult to see the work area clearly. The lamp should be placed so that hand shadows don't streak across your work. If you are right-handed, place your lamp on the left and vice versa. Glare, häikäisy, occurs when one part of the visual field is much brighter than the average brightness. Too much glare can strain your eyes and make it difficult to see objects. Glare can cause discomfort. At extreme levels, glare can even block vision. Glare may come directly from a light source or be reflected. Glare can be caused by several different things, including sunlight streaming in through windows, bright overhead lights, and computer screens that are too bright or wrongly positioned. Use adjustable lighting. Diffuse light with lampshades and use curtains on windows. Avoid direct sunlight hitting your monitor. Place an anti-glare cover over the screen. Adjust screen brightness so that the light coming out of your monitor is similar to the light in your workspace. The The best contrast settings for the monitor are also very important. The contrasty, is the luminance ratio between the brightest white and the darkest black. Setting the right contrast ratio will help keep the eyes from working too hard. The reflection of the surrounding light will reduce the contrast, so try to decrease reflected glare. Extremes of temperature, either too hot or too cold, are likely to disturb the routine functioning of the body. In Finland, work is defined cold work, kylmätyö, if it is performed in temperatures below 10 degrees Celsius. Besides temperature, sensation of cold can be caused by wind, humidity, and cold surfaces and platforms. In Finland, the term kuumatyö, hot work, is used when the ambient temperature in the work environment exceeds 28 degrees Celsius. Workers who are exposed to extreme heat or work in hot environments may be at risk of heat stress. At-risk workers include, for example, construction workers and manufacturing workers working around process-generated heat. Most of the energy we derive from the food is released as heat. Human body can gain or lose heat through mechanisms of heat exchange: conduction, convection, radiation, and evaporation. Evaporation of sweat from the skin surface has a cooling effect. It takes energy to evaporate sweat off of your skin. Our thermal balance is affected by the environment and the clothing and how loading the work is. Women have lower metabolic rates than men and need their workplaces warmer. A reasonable temperature indoors is normally at least around 20 degrees Celsius, unless the work involves severe physical work, in which case the temperature should be at least 12 degrees Celsius. Outdoor workers are at risk for cold stress. Outdoor work clothing should be selected to suit the temperature, wind speed and rain. When choosing your outdoor clothing, you should consider the wind chill, pakkasen puravuus, rather than the actual air temperature. Wind chill index, puravuusindeksi, describes the rate of heat loss from the human body, resulting from the combined effect of low air temperature and wind speed, tuulennopeus. As wind speed increases, the movement of air moves body heat away from the skin more rapidly. The combined effect of cold air and wind speed is expressed as the wind chill temperature. It represents what the air temperature would have to be in order to get the same feeling of coldness if the wind was cold. The most severe effects of cold stress are hypothermia, hypothermia, and frostbite, paleltuma. Occupational exposure to cold and repetitive work may lead to musculoskeletal problems like low back, knee, and shoulder pain. Continuous daily exposure to cold may lead to respiratory and cardiovascular symptoms. Workers who work in hot environments may be at risk of heat stress. Exposure to heat can result in occupational illnesses. Alteration in core temperature can result in heat stroke, lämpöhalvaus, or heat exhaustion, lämpöuupuminen. Sweating depletes the body's salt and moisture levels. Dehydration, nestehukka, greatly increases the risk of heat illness. To prevent heat-related illnesses, it's important to have periodic rest breaks. If the ambient temperature in the workplace exceeds 28 degrees Celsius, the employer must limit the time when the workers are exposed to high temperatures. The duration of one working period can be a maximum of 50 minutes in an hour. If the temperature rises above 33 degrees, the longest continuous working period cannot be more than 45 minutes per hour. Take your break in the shade. Drink water frequently before becoming thirsty in order to maintain good hydration. Nesteytys. Relative humidity, suhteellinen kosteus, is the amount of water vapor in the air, expressed as a percentage of the maximum amount that the air could hold at the given temperature. Warm air holds more water vapor than cold air, so the relative humidity varies with the temperature of the air. The ideal relative humidity level ranges from about 40% to 60%. In winter, the cold outdoor air has a low capacity to absorb moisture. By heating it, the temperature rises and the moisture in the air remains the same, which means the relative humidity decreases and a dry room climate is created. Long periods of exposure to humidity levels under 35% should be avoided, as they can cause eye irritation, skin irritation, and throat and nose dryness. If the relative humidity is too high, sweating as a means of regulating body temperature is impeded, and we may feel sweaty and uncomfortable. In addition, there is the risk of mold growth if the relative humidity indoors is 70% or more for long periods of time. Most workplaces have some electrical hazards. Poorly maintained or incorrectly used electrical equipment can cause fires, burns, and electric shocks. Electrical equipment and installation should be periodically checked by a qualified person. Remove the equipment from use immediately if the plug or connector is damaged. Do not fix anything unless you are qualified to do so. Do not operate electrical equipment in wet locations. Keep floors and work surfaces dry so that electrical equipment doesn't come into contact with water. Employers should ensure enough sockets are available so that they aren't overloaded. Make sure you note overloaded or damaged socket points. Lots of extension leads and adapters can result in a spaghetti of cables and plugs. They are often run over by chairs or walked across by employees, resulting in damage to the wires that can cause a fire. Cords may also cause a tripping hazard. An employer is obliged to familiarize employees with the safety instructions of a workplace and prepare them for the safe handling of equipment. A young worker must be provided with particularly careful guidance and supervision. Though it is the responsibility of the employer to make staff aware of safety procedures, it is your responsibility to make sure that you understand them. If you're unsure about a procedure, ask questions. Follow your employer's safety guidelines. Remember that they exist to keep workers safe. Thanks for watching. Goodbye.